Hi everyone, my name is Naresh, chemistry lecturer. Today I would like to discuss one of the topic from organic chemistry. For example, I am taking cherry fruit. Have you ever taken cherry fruit? And I am asking one question. So one of the chemical component present in cherry fruit. So can you say the chemical component present in cherry fruit? The chemical component is benzaldehyde. Benzaldehyde. The chemical formula is C6H5CH double bond. And do you know about cinnamon? Do you know about cinnamon? One of the aldehyde can present in cinnamon. Can you say what is the aldehyde can present in cinnamon? That is cinnamaldehyde. Cinnamaldehyde. Can you say the structure of cinnamaldehyde? Structure of cinnamaldehyde, that is CH double bond CH single bond CHO. And ripen fruits. Ripen fruits. So ripen fruits, one of the aldehyde can present in ripen fruits, that is acetaldehyde. Can you say the chemical formula of acetaldehyde? That is CH3CHO, acetaldehyde. So one of the compound, that is acetone. So what is the chemical formula of acetone? CH3COCH3. This is the acetone. So naturally it can occur from plants and trees. Naturally it occurs from plants and trees. And in these four compounds, what is the common functional group present in these four compounds? That is carbonyl group. So that's why, can we say these are carbonyl compounds? Yes, we can say these are carbonyl compounds. So this is aldehyde, this is ketone, because in the form of RCOR. It is in the form of RCHO, aldehyde. It is in the form of RCHO, aldehyde. It is in the form of RCHO, aldehyde. Today I would like to discuss two important chemical properties of these aldehydes and ketones. So one of the important chemical properties, that is aldol condensation. Before going to discuss about aldol condensation, suppose we have to know that alpha carbon. So what is alpha carbon? For example, I am taking CH3CHO, acetaldehyde. So the carbon which is connected to functional group, that is called alpha carbon. This is the alpha carbon, because this carbon is connected to functional group. And the hydrogens which are connected to alpha carbon are called alpha hydrogens. These hydrogens are called alpha hydrogens. For example, I am taking CH3COCH3, acetone. So this is the functional group. This is the alpha carbon. So these hydrogens are called alpha hydrogens. This is also alpha carbon connecting to functional group. These hydrogens are called alpha hydrogens. Total, how many alpha hydrogens are there? 3 alpha hydrogens. Total 6 alpha hydrogens present in acetone. Okay. Now we can discuss about aldol condensation. What is aldol condensation? Same in aldol condensation, aldehydes and ketones. Aldehydes and ketones which contains alpha hydrogens can involve in aldol condensation. aldehydes are ketones. Aldehydes are ketones. So which contain aldehydes are ketones which contain alpha hydrogens. Alpha hydrogens can undergo self condensation. Can undergo self condensation in presence of dilute base. In presence of dilute base, and it can produce beta hydroxy aldehydes or ketones. Beta hydroxy aldehydes or ketones. For example, I am taking acetaldehyde. So does it contain alpha hydrogens? Yes, it contains alpha hydrogens. I am taking 2 moles of acetaldehyde. When it is treated with the dilute base, it can produce CH3CHOH CH2 CHO. So this is called beta hydroxy aldehyde because it is alpha carbon, it is beta carbon. Beta hydroxy aldehyde. Beta hydroxy aldehyde. So it is also called aldol. It is also called aldol because in this compound aldehyde group can present. That's why you can write aldehyde. Alcohol group also can present. That's why it is called OLR. Alcohol. Aldehyde alcohol can present. That's why it is aldol condensation. When we coming to mechanism, first step 1. Step 1 involves formation of carbanion. I am taking acetaldehyde. So we can write like this. It contains alpha hydrogens. Thus we can write separately CHO. When it is treated with a base. So what is the nature of base? So this base can attack the proton. And can pick up the proton. Now H plus comes out. If the H plus comes out, what will be the charge present on carbon? That is negative charge. CH2 CHO. This is the carbanion. This carbanion can act as a nucleophile. Now coming to second step 2. In step 2, attacking of nucleophile on carbonyl carbon. I am taking second aldehyde, that is CH3 CHO. I am taking nucleophile CH2 minus CHO. Now CO bond is a polar bond, so this pi bond can migrate towards oxygen because oxygen is more electronegative and carbon gets partial positive charge. The carbanion can attack this carbocation. Now CH3 CO minus H CH2 CHO. Here a new bond is formed between alpha carbon and carbonyl carbon. This is the alpha carbon and this is the carbonyl carbon. A new bond is formed between alpha carbon and carbonyl carbon. Then protonation takes place. After protonation, we can get CH3 COH H CH2 CHO. So this is beta hydroxy aldehyde. On further heating, so dehydration takes place. By removal of water. CH3 CH double bond CH CHO. So this is the final product. So this is alpha carbon, beta carbon. This is alpha beta unsaturated aldehyde. Alpha beta unsaturated aldehyde. So this is about aldol condensation. In aldol condensation, so it can involve aldehydes or ketones, which contains alpha hydrogens. When treated with dilute base, we can get beta hydroxy aldehydes or ketones. On further heating, so we can get alpha beta unsaturated aldehydes or ketones. Now coming to cross aldol. Cross aldol condensation. Coming to cross aldol condensation. Here condensation occurs in between same aldehydes, that is called aldol. So condensation occurs in between, self condensation occurs between same ketones. So this is also called aldol condensation. But if the condensation occurs between aldehyde or ketone, that is called crossed aldol condensation. Crossed aldol condensation means so aldehyde and ketone can undergo condensation. We can get crossed aldol condensation product. That is crossed aldol condensation. Also, we can get two different aldehydes. Both are two different aldehydes. This is also crossed aldol condensation. So if you take different ketones, this is also crossed aldol condensation. So now discuss about crossed aldol condensation. Crossed aldol condensation always occurs in between two different aldehydes or two different ketones or some aldehyde ketone, in between aldehyde ketone. For example, I am taking CH3CHO acetaldehyde and I am taking acetone CH3COCH3 acetone acetaldehyde and acetone. And my question is CH3COCH3 acetone CH3CHO. In this acetone and the aldehyde, so carbonyl group is common. Which carbonyl group is more reactive? Which carbonyl group is more reactive? Absolutely, this is more reactive. Towards nucleophile attack, this is more reactive because here two methyl groups are there. Here only one methyl group is there. So these methyl groups acts as a bulky groups. These are bulky groups. It is one bulky group, here two bulky groups. So nucleophile can attack easily here because only one bulky group. So nucleophile cannot attack easily because two bulky groups are there. So that's why. So which is more reactive? Acetaldehyde is more reactive towards nucleophilic addition, nucleophilic attack. It is more reactive. Acetaldehyde is more reactive.